After covering the topic of brake fluid, leads us right into the next one, which is bleeding and flushing the system. Anytime you open the system or service the system, there's a good chance that you will be bleeding air from the system or flushing fluid through the system, depending on how the fluid tests on a visual inspection. If there is visible sediment, if the fluid looks discolored, we saw the amber color that it should be for most brake fluids. It's rare that you're going to have something using purple or blue fluids like the Racing 4.4 or the synthetic silicone .5. And beyond that, there may or may not be a mineral oil application that you may come across. We want to see clean, clear fluid on our visual inspection. If it's not clean and clear and amber colored like that, we're going to recommend a service on it based off of the visible condition of it, because that's just breaking down some of the interior components of the system. So whether that's the rubber breaking down on the seals and releasing a little bit off into the fluid as things are operating, or if it's from the inside of the lines, like we discussed previously, there can be some copper being stripped from the inside of the lines. And the lines that we have are very small in diameter. This is what's referred to as a banjo bolt. We have a hollow center, and we have a hole on the side of it near the top or near the head. So this is designed to move fluid through it. So that hole is not very large. And air can get trapped in these pockets, and due to the surface tension of the fluid, the air doesn't easily pass through, and we have to purge the system through. We can't expect air to just bubble its way out of there, because in order for the air pocket to move through the line, it has to displace the fluid around that air pocket. So instead of the fluid moving around, like if we had a larger diameter section, then it's going to have to be pushed through until that air pocket comes out altogether. We're going to be working with components like calipers, wheel cylinders, ABS, valve assemblies, some different types of valves. There may be crush washers that seal, or sealing washers that seal when the bolt is tightened or when the valve is tightened. And usually a banjo bolt, like in this application here, we have our fluid line coming in right to this fitting. And this fitting goes around the bolt, and the bolt passes through it. So this fitting has fluid coming into it, and there's a channel that runs all the way around it. And this bolt is a banjo bolt, similar to this. So the fluid enters the side through that hole on the port there and comes out the center. So the center of the bolt is actually carrying the fluid down into the caliper body. Before we get into the actual servicing of the fluid by bleeding or flushing, I'm going to cover something that's going to be a review for you, hopefully. Something that takes you back to your intro class with Mr. Jones. And that has to do with fasteners. This fastener here is known as a carriage bolt. There is no way to drive this. It has a square shape on the underside of the profile here to lock it in place, and it offers a nice smooth top. This is a random bolt from a boat trailer. Don't know much about it. A couple other random assortments of bolts here. Here's just regular hexagon hex bolt grade 8 fastener. This is a wheel stud. You can see the splines around here. There's no hex on that either. This is a crankshaft bolt for the front pulley or the harmonic balancer on a Honda Civic. A number of times students will tell me, oh, it's a 19mm bolt, because a 19mm socket fits on the hex. Well, that's the size of the head, and that can vary while still maintaining all the other properties of the bolt, of the fastener. So when you're talking to somebody at a parts store, or you're looking for a certain size bolt at a hardware store, or you're tracking down something, you're trying to find the information, it comes up more often than you would think. Rather than searching through bins and doing the guess and check method, you already have tools that can measure the size of the bolt without having to trek all the way into the parts room or the tool room and get out the gauge. And they're plastic, they're not always the easiest to read. so you can at least have a starting point. The best way to do that is with an open-end wrench. So the size of the bolt is going to be the diameter across the threads. This is the size of the bolt, not the hex. The size of the bolt. Anytime any instructor or anybody's asking you what the size of the bolt is, they're referring to this portion. We have a length and we have a width. The width is our size. So what size is it? Well, do we know if it's metric or standard? Well, I know it's off of a Honda, but let's say we didn't know that. This does not fit. So it's not a 9/16. It's larger than a 9/16. This one happens to be 16 millimeter. Quick, easy way to check. You have your wrenches on hand, you can check the size of a bolt. It works for other ones too, like this big one that we were looking at earlier. Off a boat trailer. Could have come from anywhere. Boat trailers lead some odd lives. Is this a 13? Could be a 13. Could also be a 1/2 inch. 1/2 inch is a little tighter on there. 13 millimeters and a 1/2 inch wrench. They are not the same. 13 is slightly larger. Always use the correct size wrench for the fastener. Same with the carriage bolt. What size is that? Is it 3/8? No, too small. Let's step it up to the 1/2 inch. Again, 1/2 inch fits nice and snug. See that? And this also translates to bolts like banjo bolts. As long as they are cut straight, 10 millimeter. It's a quick, easy way to find out what size bolt and whether it's metric or standard. This bleeder screw right here. Bleeder screw is 8 millimeters. At that point, you'll know if it's standard or metric, and makes the process of finding that thread chaser or the thread file or the tap or the die a little easier to find. Which brings me to another point. How do these seal? If we have a fastener like this, and it's the same diameter all the way down, there are fasteners, plugs, and fittings that do have a taper. Those are a different design. They're called pipe thread. So pipe thread versus straight threads. And what does that have to do with sealing? Well, on this example, this is our bleeder screw. And I've drawn a crude example of this shape. So we have a hole down the center going down through the middle of this bleeder screw, or bleeder valve, used interchangeably, coming down to this little hole on the side. This is the example I've drawn here. The blue indicating the path where the fluid goes. Comes down to the hole, and then it comes out the side and then enters into the component that it is sealing. Our sealing surface is right on this tapered seat. So right here and right here on both sides. So when this bleeder is threaded down into this bore here, as we tighten it, not over tighten, but as we snug it, this tapered seat is going to seal against that tapered seat down there. The tapers match each other. And this is going to prevent fluid from backing out of our component that we're trying to keep sealed. The other way that threads can seal are by having tapered threads, or pipe thread, usually abbreviated by NPT. As the threaded fastener or the threaded plug or the fitting is spun down into the matching taper bore of the component, these threads will actually tighten against each other because they form a wedge, whereas this style is straight. Now this is going to come in handy when we are talking about how fluid behaves running through our bleeders. You will not see this type of thread design when we're working with our bleeder screws or bleeding valves during the bleeding and flushing procedure. But you may come across them somewhere in the system. So don't rule them out, just want to make you aware. There are a few different methods for how to move air out of the system. The most common way is to use a pressure bleeding machine. Another common way is using a vacuum. Another method is to use two people, one person at the brake pedal operating the brake pedal stroke while communicating with somebody at the bleeder valve who is opening and closing during certain times to allow fluid to come out with any air in the system, and then to seal it before any air can get back in. The final method, and probably the slowest method, is gravity bleeding. After servicing the system, there may be air pockets in the hydraulic system. Why is it important that we remove this air from the system? Because air can be compressed, a soft, spongy pedal, due to the air compressing in the system and not allowing us to operate our brakes to their full potential, which is a safety concern. You step on the brake pedal, or a driver steps on the brake pedal, they expect the vehicle to slow down reliably. Vehicles are now required to have anti-lock braking systems, ABS. And those valves in the systems that are operating by module depend on having zero air in the system in order for that quick, rapid movement to be able to move fluid, shut fluid flow off, recirculate fluid, and move fluid again many times a second. The valve may be rapidly actuating back and forth, but the fluid may not be flowing through there because there's an air pocket. Air needs to be removed from the system in order for it to work properly and for safe handling of the vehicle and operation of the brake system. The first method I'm going to go over is the gravity bleed method. So this is essentially I'm eliminating most of the vehicle here. This is our master cylinder reservoir. On a typical system, our master cylinder is the highest point. Just as the name suggests, gravity bleeding uses gravity to help pull that fluid down. Gravity bleeding is just like this. You go to the bleeder and you open it, maybe a quarter of a turn, and it's going to take a little bit. You can see the fluid making its way out of that bleeder screw, running down and dripping off of the caliper housing. The likelihood that you'll have to be doing any gravity bleeding is very slim. I'm not saying that you won't encounter a tricky system that's not easy to bleed, because that will happen, and you may be forced to service the system by gravity bleeding, which takes a long time. The nice thing about it is you can do multiple bleeders at the same time. Depending on the bleeding sequence, you may be bleeding multiple components in a seemingly random order. Gravity bleeding can be done on just about any system. Now, there are valves that can be in the system that need to be bypassed in order to allow fluid to move around them. Some valves in the system need some initial pressure in order for things to unseat and allow fluid to pass through. Some valves will have a button on them to be depressed, and that will allow fluid to flow through without any pressure, allowing you to gravity bleed the system. The next method is to do a pressure bleed by actuating the master cylinder by use of the brake pedal, where somebody is sitting inside the vehicle and the technician is down at whichever wheel or valve needs to be bled first or next. The person at the bleeder needs to have clear communication with the person in the driver's seat, and the person in the driver's seat needs to communicate clearly with the person down by the wheel. This can be challenging in a shop environment where there's many ambient noises going on and it's hard to hear. So windows down on the vehicle is the best way to do this. Better than having the doors open and having things in the way that you can possibly damage or get injured by. And the person down at the bleeder is doing the work and the bulk of the communication, stating when the person should hold pressure on the brake pedal and actuate pressure, when to let go of pressure on the brake pedal, when they are opening the bleeder, when they are closing the bleeder, and when the person in the driver's seat can just wait for the next set of instructions. Also, the person in the seat should be communicating clearly with the technician when they are doing whatever is commanded of them, when they've done the motion, fulfilled the instruction, and then when they are done with it. So that will be a communication thing between the partner and the person bleeding the brakes. The next method that I'm going to cover is vacuum bleeding. The brake system operates on pressure generated by the driver or by a module actuating solenoids or the driver pushing on the master cylinder, and that is going to force fluid to move through the system and apply the brakes. Because it's designed to operate on pressure, vacuum bleeding doesn't always work. Vacuum bleeding actually takes a pressure differential at the bleeder screw, and by putting a pressure differential on it, you're using atmospheric pressure to push the fluid through the system by creating a lower pressure at the bleeder screw. This method takes a tool. It looks like this. It has a hose on it. It connects to compressed air. By pressing this down, it will force air through the nozzle. And that nozzle assembly, the valve here, will actually bypass another port, and it creates a low pressure down in this chamber. Gives us our pressure differential. Pressure at sea level is 14.7 psi. Now that number goes down the higher you get in elevation, but for all purposes that we're discussing, we'll stick with 14.7. That's going to force the fluid to go from our 14.7 psi atmosphere to the lower pressure inside of our container. So this is how this tool works. When you press this down, it is creating a suction here at this end here, and this end is actually designed to slip over a bleeder screw, creating a adequate seal around there and helping to draw that fluid out. Now when you're working with this tool, you may need to have your hands free. So what you can do is depress this and flip this over the handle, and it'll keep it in the locked position. We have our wrench on our bleeder. Now bleeder screws can get stuck, and it may be necessary to use penetrating lubricant or use a shock on the end, like with an air hammer. Being very careful not to produce too much impact on this piece, but where that tapered seat comes down and it has that seal, rust and contaminants and debris can get down in that area and prevent this bleeder screw from turning. Bleeder screws can break. They're hollow in the center. They're not as strong as a normal bolt. So using as much care as possible is going to be key in removing and servicing these systems. If you break a bleeder off, you may have to replace the caliper. We always want to use the box end of a wrench. Right now I'm using a 12-point. It's better to use a 6-point if you have a 6-point box end wrench available, because the 12-point wrench has little spaces in between each of the teeth that are engaged to the bleeder screw that are not going to be as strong as a complete side or a flank on that hex. So if we can, use a 6-point. Otherwise, 12-point, always use a box end. Position the wrench in a way that when we open the bleeder valve, we have room for the wrench to move. If we started loosening up here, our wrench is going to hit the caliper body and we won't be able to open the bleeder all the way. So we'll position the wrench down at the bottom. And this is how it goes. Slip this over the bleeder. Before we open it, we're going to allow this to provide that pressure differential. Then open the bleeder. We now have fluid flowing through the hose. You can see the level in here is dropping because it is being pulled through the line and coming out of the bleeder. Before we turn the pump off, we're going to close our bleeder and snug it just a little bit. That's all you need. Now we've displaced the fluid into our container. Using that method, you may have air pockets coming through the tube as you're removing fluid with it, especially with the vacuum system. Now remember what we discussed with our bleeder screws and not being tapered. So when this is unseated from the sealing surface, which is down on this little taper down here, once this is just opened and maybe just a quarter of a turn, just a little bit, that's enough to unseat this and allow fluid to come around that seal, enter the side of the end of it down here on the hole, and then travel through the center and out to the tube. Air can be pulled down on the sides through the threads of the bleeder screw. So not only are you removing fluid from the component, but air can be traveling down through these, along past these threads, since they're no longer tight and this is no longer seated. You may have air coming down here, entering into the bottom port and being pulled up through the rest of the bleeder screw with the fluid that you're removing. So seeing air bubbles coming from the tube is not always an indicator that there's still air in the system. It's going to be more important that the pedal feel is firm when the engine is off and the power assist is depleted before determining that you need to do further bleeding. Just the presence of air coming out through the tube is not always an indicator, especially with vacuum bleeding. The final method for bleeding brakes, and often the most popular and most reliable method of bleeding brakes and flushing the system, is to use a pressure bleeder. A pressure bleeder will adapt to the reservoir of the brake system up by the master cylinder, and with different configurations of adapters, it's going to provide a seal to the reservoir or to the ports down at the bottom of the reservoir, and it's going to use no more than 30 psi. 30 psi is our maximum. Start at 0 and then ramp up your pressure until you have fluid flowing. Oftentimes, you don't need anything more than 5 to 10 psi. As it is pumping fluid, it's going to pressurize the system. I have my own homemade little container here out of an old 2-quart jug where I have a piece of hose or tubing that I can hang with a piece of coat hanger bent. I can hang from a chassis or suspension component and put this over the bleeder screw with our wrench in place and that on there. We have the machine set up and following our bleed sequence. We go around to each port and open the bleeder and allow that machine to push the fluid through the system, operating under pressure like the system is designed to operate. So ideally, if you can, flush the system, bleed the system with the pressure bleeder. It is the best way to do it if you can do it. Worst case scenario, you have to do a gravity bleed, and it takes a long time to do. Always, always, always replace your bleeder caps. By replace, I mean put back on. If it came off, put it back on. That way it protects that port from dirt and grime. This part is down at the wheel, hitting every little bump and getting into all the different road grime that somebody may drive through. Always replace your bleeder screw caps so that the port is always protected from the elements, and that will minimize the amount of work for the next person or for the next time you're servicing that system. I want to cover a little bit about bleeding sequences and how that all works. On each vehicle, there are multiple ports that need to be opened in a correct order in order for all of the air in the system to be reliably mitigated from the system. So each vehicle should have its own bleeding procedure. The first example that I'm going to show you is for my 1996 Honda Civic. The bleed sequence for a 96 Honda Civic is right rear, left front, left rear, right front. And that's going to be the front of the vehicle. When we're determining right and left and front and rear of a vehicle, front and rear is pretty obvious. Left and right is always from the driver's perspective. The right rear is going to be back here. That's our first port. And then the left front. Now notice where these are. Are they both on the rear or are they both on the front? One is, the first step is right rear, the next one is left front. They are diagonal. Then we're going to the left rear. So driver's side rear for our third port to bleed and service. And then our last one in this sequence is the right front. It's a front-wheel drive vehicle, 1996 Honda Civic. Most of the weight's up front. Hydraulic systems may be split in order for safe operation in case we had a leak on half the system. It's a diagonal split. So by starting here, going there, then back to the left rear, and then finishing on the right front, that sequence shows us that we likely have a diagonal split system. And that is in fact the system that we have on the Civic. The next bleeding sequence that I'm going to cover is on an older vehicle. So this is the actual procedure for bleeding the brakes on my 1978 Datsun pickup. Being an older truck, rear-wheel drive, 4-cylinder, you would think it'd be pretty straightforward. So let me show you what's going on here. And we'll just put an oval here for the master cylinder by the driver. And this also has something else in it. Being a pickup truck, the chassis height can vary depending on how much load it has in the truck bed or if it's towing something. So Nissan came up with a valve called the Nissan Load Sensing Valve. And this lives along the frame rail just behind midway on the right side of the vehicle. So this is the bleed sequence. Master cylinder front port. Second, master cylinder rear port. And then it states front calipers, either one first. And then we go to the NLSV, which is the Nissan Load Sensing Valve. Front port. Then our sixth location is the left rear wheel cylinder. Seventh is the right rear. Then the NLSV rear port. And finally, the NLSV middle port. So 9 steps to bleed that system. And if you have to do it again, you start back at step 1. And you go all the way through to step 9. Even though a vehicle may seem simple, there may be a complex or more complex method of bleeding than you would initially think. So we don't want to assume. We always want to follow specific procedures outlined in service information for each vehicle. There are a few things that we have to determine before we consider this to be our best option for bleeding the system. That involves looking at service information as much as possible to rule out any information, looking maybe for some online searches through Google or even YouTube, but sifting through some of the incorrect information or just the stuff that doesn't match isn't always easy. And finally, we have to look at the design of the system. Can we look at the lines? Can we see where they go? Can we determine by looking at the system if it's a front-rear split, is it diagonal split, does it have an ABS unit, does it have other valves like the Nissan load sensing valve or something similar to that that also needs to be bled? That's when we need to have more information. But if we see that the system is generally simple, there is an ABS on it, it's a front rear split, the chassis is a pretty much even weight distribution, this is a pretty safe way to go. But we don't want to just shoot from our hip and take that route without looking into it and determining as much as we can before doing it. So we've covered our topic of bleeding and flushing fluid, and when we get to do this in person, I hope it makes a lot more sense than just the theory of it, but it is a very critical step in servicing the brake system and mitigating any air from the system. Thank you very much.